This presentation is entitled Categorizing Structured Data. Now today we live in an information system era. With an information system, you're able to ask certain kinds of questions. Take, for example, an electronic healthcare record system. You may have a database table, and in this table you may have a column of patient names and another column of diagnosis associated with that patient. So with an information system, you're able to ask certain kinds of questions. For example, tell me all the patients in the hospital that have Crohn's disease or ulcerative colitis. What you can't do with an information system is ask higher level kinds of questions. For example, tell me all patients in the hospital that have digestive system diseases or autoimmune diseases, higher level kinds of concepts. So in this presentation, what we talk about is a way of categorizing structured data ontologically to enable the ability to ask higher level kinds of questions.
Categorizing structured data. There are many challenges associated with information technology. In today's presentation, we're going to focus on interoperability. Today, in order for enterprise systems to talk to one another, they send messages back and forth via typically something like XML. There are a number of steps associated with providing the ability to query on structured data. Today we're going to look at two of these steps, creating a knowledge layer via something called ontologies, and use of this knowledge layer to categorize data in a warehouse. We're going to look at a number of categorization examples, particularly in the field of healthcare. So we're going to look at ontologies, healthcare ontologies, something called UMLS, and a few other kinds of healthcare ontologies outside of UMLS. We're going to look at something called value sets, in particular quality measures, something called NQF or AHRQ. We're going to look at healthcare documents. These are basically XML documents here and of various types here. And we're going to look at terms that can be categorized via natural language processing, the ability to take nodes in a graph and be able to categorize them ontologically from a healthcare perspective. We're going to start by doing a little graph theory here. In front of us are two graphs, a family tree and a graph of bus routes. Some of the components of a graph consist of the following: the notion of something called nodes. In this family tree graph, the nodes happen to be the names of people here. A second component of graphs are these things called connections here, or edges. And they happen to be the arrows we see between nodes here. Sometimes in graphs, you have a semantic relationship associated with these arrows. In this family tree graph, we have a father of relationship, and we have a mother of relationship. Sometimes with graphs, you have scalar values associated with the connections. In this bus routes example, the scalar value represents a cost of going from one city to another. Let's look at the difference between data versus information versus knowledge. If I showed you the following, would you consider this to be data or information or knowledge? Well, it turns out it's just data. And the reason why is because you look at this and it looks like a column of names. That's because it is something you recognize. This looks like a column of diseases. That's because you're familiar with it. But by itself, it is merely data, just text strings. Now, if I add column headers here, these column headers are what are known as metadata. And so what we get is data here plus metadata is our definition of information. Well, what if I take and put an overlay here, the following? We see type 1 and type 2 diabetes are specializations of this more general category of diabetes. Ulcerative colitis and Crohn's disease are specializations of this more general category called digestive diseases. So what do you call this structure here, this knowledge overlay? I call it meta-information. And so my definition of knowledge is information plus meta-information. This knowledge overlay here is something called an ontology here. There are semantic relationships between the nodes here. And what this allows you to do is the following. If you view this as a relational table here, you can certainly ask questions about who has type 1 diabetes in your database here. What an ontology overlay allows you to do is ask higher level questions. Tell me all the people in my system that have diabetes in general or have autoimmune diseases in general. The first example we're going to look at is with respect to ontologies. We're looking at something called UMLS, Unified Medical Language System. It's a collection of over 150 vocabularies / taxonomies / ontologies here. So you see something here called ICD-9, SNOMED, LOINC. These are 3 of the over 150 vocabularies. So it's a collection of nodes or vocabulary terms and semantic relationships between all the terms. And you can see in this diagram that, in fact, nodes in one vocabulary potentially point to nodes in another vocabulary. Here's a closer look at the SNOMED vocabulary in a tool here. And we see SNOMED here, the root at the top here. And it turns out there are over 400,000 vocabulary terms associated with the SNOMED ontology. Here's a closer look at one of the vocabulary terms, or nodes, in SNOMED. We're looking at the acute myocardial infarction node here. And above it we see the parents associated with this node, and below it we see the children. And notice the different connection types associated with the various parents and children. Here's another close-up of SNOMED. Here we see a node called clinical finding here. Here we see a descendant called acute heart disease. Notice here that there are multiple paths going from clinical finding to heart disease here, acute heart disease. It's a reflection of the fact that SNOMED isn't a single hierarchy, it's something called a polyhierarchy, or a directed acyclic graph, a DAG. Here's another categorization example. In this case, it deals with value sets, in particular NQF quality measures here. And so what you see here is basically an XML document that defines a quality measure specification. Here's an example of a healthcare document dealing with clinical trials here. This happens to be the output of doing a query at clinicaltrials.gov. You see again, it is an XML document. Here's another healthcare document example, a categorization. It is a CDA HL7 document. Again, notice it is XML. One of the bold claims I've made in my presentations is the ability to write a generalized query that can be executed on any structured data. So let's look at an example here. I created, just for the fun of it, a little hierarchy here entitled Tom's Social Collaborative Network. And it's broken down into family members and healthcare professionals and friends and different subcategories here. And imagine that within each of these categories is a list of people. So let's say what I would like to do is write a query that says, find all the people in Tom's Social Collaborative Network that have something to do with healthcare. So what I can do with the TC-SQL capabilities is the following. I can execute a natural language processing application on any of the nodes here. So in the example here, I'm going to execute it on endocrinologist here. And what this NLP is going to do is return a set of industry standard codes associated with the ontology called SNOMED here. And it's going to return an XML document here. Well, I just demonstrated the ability to import any XML document. And so it'll look like the following here. So given a node here, I can attach the XML document returned from natural language processing here. So now what I've done is provided an unbelievably powerful ability to take any structured data here and ontologically categorize any of the names or values associated with the names of any nodes in a graph. So what have we learned from this presentation? First of all, we've demonstrated the ability to import any kind of XML. And you can see through the various examples in this presentation, really XML is everywhere. It's the common standard way of enterprise systems to talk to one another. We've demonstrated the ability to categorize any graph node name or value within any domain context.